How does kinetic energy power speeding objects? Imagine watching a roller coaster climb up a hill and then zoom down at incredible speeds. What makes that sudden rush of motion happen? It all comes down to kinetic energy. Kinetic energy is the energy an object has because of its movement. When something moves, it carries this energy, which depends on how heavy it is and how fast it's going. The faster an object moves, the more kinetic energy it has. In fact, kinetic energy increases with the square of the speed, so doubling the speed makes the energy 4 times greater. This is why small increases in speed can lead to big jumps in energy. Kinetic energy is what powers objects to move faster. Think about a car accelerating. The engine does work on the car, pushing it to go faster. As the car speeds up, its kinetic energy grows larger. That energy is what allows the car to keep moving and do work, like overcoming resistance or pushing through air. When the car hits something, that kinetic energy doesn't just disappear. It transforms into other forms, like heat from friction, sound from the impact, or deformation of the materials involved. From a thermodynamics point of view, kinetic energy is closely linked to heat transfer and how molecules move. In gases, the faster the molecules move, the higher the temperature. When molecules move quickly, they bump into each other more often and with more force, which affects pressure and heat flow. This molecular motion is a form of kinetic energy that underpins many heat and energy transfer processes. Kinetic energy can take different forms depending on how things move. When an object moves from one place to another, it has translational kinetic energy. For example, a speeding bicycle or a rolling ball. When an object spins around an axis, it has rotational kinetic energy, like a spinning top or a flywheel. Vibrational kinetic energy occurs when molecules vibrate, which happens in solids and liquids. Think of a guitar string vibrating after being plucked. In real life, we use kinetic energy in many ways. Flywheels store energy in rotational form to keep machines running smoothly. Vehicles turn chemical energy from fuel into kinetic energy to move forward. Safety features like crumple zones in cars are designed to absorb kinetic energy during collisions, reducing injuries. So, in simple terms, kinetic energy powers speeding objects because it measures the energy they have because of their motion. The more massive and faster an object is, the more energy it carries. This energy allows objects to do work and interact with their surroundings. Understanding this helps us see how motion, energy transfer, and heat are all connected in the world around us.